Hi there, and welcome to this course on Introduction to Geographic Information Systems, or GIS. My name is Kate, and I am a GIS expert with 10 plus years experience in these topics. I also teach and train people on GIS and remote sensing and give regular courses at different parts of the world, including both universities, academia, and private sector. And today I am delighted to introduce you to this interesting topic. GIS is an important part of our daily life, though many people do not realize this. From learning to code, to building web maps, or doing data collection in the field, if you want to learn GIS, it's never too late. And don't forget, once you learn these skills, you are like the talented Mr. Ripley, because these are all transferable talents. For example, cartography applies to graphic design, as does automation to programming. The main aim of this course is to introduce you with the basic concepts of GIS and GIS datasets. This should be regarded as a first basic course that form a background for an advanced courses in GIS. So stay tuned and follow my updates. During this course, we will learn the following topics. What is geographic information systems and where we use it? What are the main principles of GIS and what are the typical GIS functions? Where do we apply GIS? I will provide you with a few examples. We will talk about GIS applications, as well as I will provide you with an understanding of GIS system components. I will equip you with a list of GIS software packages that you can use to get started with GIS. As well as I will talk about data portals to obtain special data sets for free. This course is perfect as an introductory course for GIS to get basic knowledge of this interesting subject and to equip you with the knowledge of available GIS software packages and special datasets. So, let's get started. Hi there, and welcome back to this course on Introduction to Geographic Information Systems, or GIS. My name is Kate, and let's get started. The topic of today's lecture is how to define GIS and what is GIS. What is the definition of GIS? A geographic information systems, as can be seen from this slide, is a framework designed to capture, store, manipulate, analyze, manage, and present spatial or geographic data. GIS applications are tools to allow users to create interactive queries, user-created searches, analyze spatial information, edit data in maps, and present the results of all these operations. Rooted in the science of geography, GIS integrates many types of data. It analyzes spatial location and organizes layers of information into visualizations using maps and 3D scenes. With this unique capability, GIS reveals deeper insight into data, such as patterns, relationships, and situations, helping users make smarter decisions. In the next lecture, we are going to learn main principles and components of GIS. So stay with me and see you later. Hi there, and welcome back to this course on Introduction to Geographic Information Systems. My name is Kate, and let's get started. Today, we are going to learn main principles, stages, and components of GIS. At the end of the lecture, you will be able to define GIS and understand its main components needed to apply for your future GIS project. Okay, let's get started. Main principles of GIS. GIS can relate unrelated information by using location as a key index variable. Locations or extents in the Earth space-time may be recorded as dates times of occurrence, and x, y, and z coordinates represented longitude, latitude, and elevation respectively. All Earth-based spatial temporal location and extent references should be relatable to one another and ultimately to a real physical location or extent. Geographic information system really comes down to just 4 simple ideas. Create geographic data, manage it, analyze it, and display it on the map. Hundreds of thousands of organizations in virtually every field are using GIS to to make maps that communicate, perform analysis, share information, and solve complex problems around the world. This is changing the way the world works. Main stages of GIS analysis are shown on the slide. Namely, they are identification of the problem, monitoring change, managing and responding to events, performing forecasting, setting up the priorities, and understanding the trends. Now let's talk about how GIS works. GIS technology applies geographic science with tools for understanding and collaboration. It helps people reach a common goal to gain actionable intelligence from all types of data. For this, GIS uses maps, data or geodata, analysis, and apps. Let's now talk about each of these components. The first component is the maps. Maps are the geographic container for the data layers and analytics you want to work with. GIS maps are easily shared and embedded in apps and accessible by virtually everyone and everywhere. The second component is data or geodata. GIS integrates many different kinds of data layers using spatial location. Most data has a geographic component. GIS data includes imagery, features, and base maps linked to spreadsheets and tables. The third component is analysis or spatial analysis. Spatial analysis lets you evaluate suitability and capability, estimate and predict, interpret and understand, and much more, lending new perspectives to your insights and decision making. The last component is the apps. Apps provide focused user experiences for getting work done and bringing GIS to life for everyone. GIS apps work virtually everywhere, on your mobile phones, tablets, in web browsers, and desktops. Now, as you have learned main structure of GIS and know how to define it, let's talk about the software packages that are available for GIS analysis. This will be the topic of the following lecture in the course. Hi there, and welcome back to this course on Introduction to Geographic Information Systems, or GIS. I'm Kate, and let's get started. The topic of today's lecture is on GIS applications. Let's review some examples. If you know more examples, do not forget to mention them in our course discussion sections. Every day, millions of decisions are being powered by geographic information systems, from pinpointing new store locations to predicting climate change to reporting power outages to analyzing crime patterns. You might be wondering, but why we use GIS? Because geographic problems require special thinking. In a GIS, you connect data with geography and you understand what belongs where. Because you don't fully understand your data until you see how it relates to other things in geographic context. As seen on this slide, GIS has numerous applications, and I would like to review some of them. My first example refers to applications of GIS in agriculture. GIS is often used to support decisions in agriculture. Some examples of such applications are following. GIS is used for precision farming. GIS could be used to harvest more bushes per hectare while spending less on fertilizer using precision farming and software. GIS is also used for disease control. GIS could be used to combat the spread of pests by identifying critical intervention areas and efficient targeting control interventions. 3D scanners for biomass. GIS is used to measure with laser accuracy 3D biomass, for example with Faro scanner. We can use GIS for real-time crop yields, shifting to real-time crop monitoring and targeted automated response with drones and precision watering sensors. We are also using GIS for irrigation management. GIS could be used, for example, to capture irrigation infrastructure for land management decisions. And this list does not stop here. It could continue on the other different applications of GIS for agriculture. My second example is on the use of GIS to power business decisions. Some examples of such applications are following. GIS could be used for direct marketing. GIS is used for revitalizing selling strategies by reaching out to customers directly with location intelligence. GIS is also used for drive time analysis. Those analyses are usually determine a trade area based on how long a customer must drive to get to the store. This use take into account functioning in street speed limits, traffic volumes, and other impedance. GIS is also used for Internet of Things to improve efficiency, accuracy, and economic benefits through a network of physical objects such as devices, vehicles, buildings, and other items, embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange information with one another. GIS is used also for nearest allocation analysis, to resolve the nearest gas station, restaurant, or coffee shop using GPS-based positioning and geocoding business data, and so on. GIS is also used to empower decision in land use planning and management. It is one of the most prominent applications of GIS. Some examples of such applications are following. We use GIS for urban model development feasibility. We can use GIS for land use conflict identification modeling. For food deserts, so for example, GIS is used to access grocery stores in low-income area by incorporating information such as sidewalks, bicycle lanes, and public transport. GIS for service areas planning. We use GIS to measure how far paramedics and firefighters can service an area. OpenStreetMap. Everybody knows this GIS application for land use management. Text parcel viewers. GIS is used to assemble text parcels, zoning information with color schemes on a web viewer, and so on. My last set of examples of GIS applications refer to the use of GIS to support decisions in climate change. For example, NASA Earth Observatory, exploring the cases and effects of climate change of our atmosphere, oceans, land, and life through the use of satellite data and GIS analysis. Climate change skeptics, the use of GIS to turn skeptics into believers. Maps make climate change findings easier for skeptics to understand and accept. Pollution modeling, mapping air pollution sources and impacts on environment and people. Bird risk and richness, using GIS to study the effects of shrinking habitats on bird population in the world. Climate change design, redesigning to accommodate climate change and pinpointing those locations needed most. Land change modeler. This is a special modeling tool based on GIS analysis which is incorporated in TerSat land use change modeler. We are going to talk about this GIS software a little bit later in this course. This GIS modeler module includes special tools for the assessment of RED, reducing emissions from deforestation and forest degradation, climate change mitigation strategies, and so on. The list of the GIS applications is not finishing here. More applications include, for example, Internet GIS applications, GIS for crime applications, insurance application, humanitarian applications, environmental and energy applications, real estate applications, use of GIS for transportation planning, utilities applications, open technology applications, and many others. Hi there, and welcome back to this course on Introduction to Geographic Information Systems, or GIS. My name is Kate, and I want to congratulate you to reaching out the final 2 lectures of this course. The topic of today's lecture will be on geodata. Today, we are going to learn about data that is used for GIS analysis, or geodata. We are also going to talk about 2 main types of geodata, which is vector and raster data types. What is geodata? Geodata is location information stored in a geographic information systems. By viewing data with a geographic component, we see it through a different lens. Geodata tackles the problem about location because geographic problems require special thinking. Let's dive into the types, themes, and sources of geodata. As it turns out, there is not one single type of geodata. Instead, geodata exists in various forms. For example, we commonly use vector and raster to depict geodata. First of all, let's talk about vector data. Vector data consists of vertices and paths. The three basic types of vector data are points, lines, and polygons, or areas. Each point, line, and polygon has a special reference frame such as latitude and longitude. First, vector points are simply xy coordinates. Secondly, vector lines connect each point or vertex with path in particular order. Finally, polygons join a set of vertices, but it encloses the first and last vertices, creating a polygon area. Now let's move and talk about raster data. Raster data is made up of pixels or grid cells. Commonly, they are square and regularly spaced, but rasters can be rectangular as well. Rasters associate values to each pixel. Continuous raster have values that gradually change. The examples of continuous rasters are elevation or temperature layers. But discrete rasters set each pixel to a specific class. For example, we represent land cover maps to a set of values. We will cover this topic in more detail in the upcoming courses. Now, let me show you a great source of geodata that you can use to your project. Let's meet in the following lecture. Hi there, and welcome back to the lecture number 5 of the course on Introduction to Geographic Information Systems, or GIS. Today, we are going to learn how to set up GIS on your computer, specifically what you need to run GIS analysis. We will also talk about software tools available for GIS analysis for free. In order to be able to start GIS analysis, we first need to understand what are the main parts of GIS in practical terms. Technically speaking, GIS consists of hardware, software, data, and applications. Thus, to be able to run GIS analysis, you will need a computer powerful enough to handle special data, specialized software, for example QGIS or commercial ArcGIS software, and of course, GIS skills. The latter we will master in this course as well as my follow-up courses. So if you are interested in this subject, I do encourage you to follow my updates for new upcoming classes on the topic of GIS and remote sensing. But for the moment, let's talk about a bit more about requirements for your computer and software tools that you can use for GIS analysis. If you are looking to purchase a computer with optimum system requirements for GIS work, there are certain specs you should be aware of. An inadequate hardware setup will result in your GIS software hanging or crashing when attempted to process large GIS datasets. Something to bear in mind, some of the specifications also partly defined by the requirements of the specific software package that you will use. Esri provided hard requirements to running ArcGIS 10 on their website. Their OSGeo wiki has also GIS workstation setup tips. Listed here on this slide computer specs to take into consideration when running GIS software in a Windows environment, which is required for running ArcGIS. QGIS, which can run on Linux, Macintosh, and Windows operating systems, doesn't offer formal hardware requirements, but you can use these requirements that I'm going to tell you today as a roadmap for yourself. To be able to run GIS software and analysis, you would need to pay attention for the following components of your PC: RAM, SPU speed, hard drive storage, processing, and graphic card. Let's start with the RAM. RAM. To run intensive GIS data processes or complex spatial analysis, it is important for your computer to have an adequate amount of RAM. For running ArcGIS software, make sure you have at least 8 gigabytes of RAM, but preferably 16 gigabytes or even higher. SPU speed. Make sure your computer's SPU speed is adequate. The ArcGIS 10 system requirements recommend 2.2 GHz minimum, HIPAA threading or multi-core processing. Hard drive storage. Make sure your hard drive is large enough to store GIS data. If you are working with a large geographic area or are using high-resolution satellite imagery, you will need plenty of space to store GIS data that can easily be 1 gigabyte or even larger. A SSD drive has been reported by many GIS users to be a more robust option. 64-bit processing. Starting with a version 10.1, ArcGIS can now perform 64-bit background geoprocessing. To use this, your machine will need to have a 64-bit operation system, which is logically. Additional, the posts by Esri staff says that 30-bit applications such as ArcGIS Desktop can access almost twice as memory when you run it on the 64-bit operating system. Graphic card. If you plan to work within a 3D GIS environment, make sure you have a graphic card capable of handling 3D display. Esri require OpenGL compatible graphic cards to run 3D analysis. Now, as you know how to correctly equip your PC, let's talk about software packages available for GIS analysis. There is quite a long list of commercial and open source software that can be used for spatial analysis. On this slide, you can see some of the examples, such as ArcGIS. That is probably the most used GIS software in the world, though it is also quite expensive. DARSAT, formerly Idrisi from Clark Labs, compared to ArcGIS, it's much more cheaper and it's more affordable, and it also has beautiful packages for both GIS remote sensing analysis and land use modeling. So different models are incorporated in DARSAT software, which is a unique strength of this software package. GrassGIS and of course QGIS. While some companies spend thousands of dollars on remote sensing software and GIS software, just remember that you might be able to do all this analysis in open source. The best part is, the free GIS software gives you the firepower to get the job done as if you are working with commercial GIS software. I have mapped out the GIS software landscape, and in the following slides, I'm going to present for you my 5 top most favorite open source GIS software. And of course, QGIS is undoubtedly the number one free GIS software packages, and of course, it's a top on my list. QGIS is a jam-packed with hidden gems at your fingertips. For example, you can automate map production, process geospatial data, and generate draw-worthy cartographic figures. There is no other free mapping software on this list that lets you map like a rock star than QGIS. QGIS plugins boost this mapping software into a state of epicness. If the tool doesn't exist, search for a plugin developed by the QGIS community. Volunteer effort is key to the success of QGIS. The QGIS Start Exchange support is impressive grade. QGIS 3 brings a whole new set of cartography, 3D, and analysis tools. Downside of QGIS that is worthwhile mentioning. Frequent software updates result in bugs and changing layout of the program that of course could slow down your spatial analysis when you are used to another layout and if you are stumped on the back. My another top GIS software referred to the GVSIG project, which started back in 2004 in Spain. This software really outperforms QGIS for 3D analysis. It's really the best 3D visualization available in open source. The nav table is a guile in that it allows you to see record one by one vertically. The CAD tools are impressive on this software package. Thanks to the open CAD tools, you can trace geometries, edit vertices, snap and split lines and polygons. If you need GIS on your mobile phone, the mobile version of this software package is perfect for fieldwork because of its interface and GPS tools. GrassGIS, or Geographic Resources Analysis Support System, was developed by the U.S. Army Corps of Engineers as a tool for land management and environmental planning. It has evolved into a free GIS software option for different areas of study. Academia, environment, consultants, and government agencies such as NASA, NOAA, USDA, and USGS use GrassGIS because of its intuitive interface and its reliability. It has over 350 rock-solid vector and raster manipulation tools. Not all fully useful in cartographic design though, GrassGIS excels primarily as a free GIS software option for analysis, image processing, digital terrain manipulations, and statistics. My next example is Whitebox GAT or GAT, Geospatial Analysis Toolbox, and it is one of the top list open source free GIS software. Unbelievably, Whitebox GAT has only been around since 2009 because it feels so fine-tuned when you see it in action. The rare hydrology theme around Whitebox GAT. It actually replaces Terrain Analysis System or TAS, a tool for hydrogeomorphic applications. Whitebox GAT is really a full-blown open access GIS and remote sensing software package. Where it shines is LiDAR. With no barriers, Whitebox GAT is a Swiss Army knife of LiDAR data. The LiDAR toolbox is a lifesaver. For example, LIS to shapefile conversion is an insanely useful tool. but you may need a Java update to go in full strength of this software. The cartographic mapping software tools are primitive compared to QGIS, but overall Whitebox GIT is solid with over 410 tools to clip, convert, analyze, manage, buffer, and extract geospatial information. I find it amazing that this free GIS software almost goes unheard in our GIS industry. Get more useful knowledge from the Whitebox GIT open source blog. And my last example and the last top GIS open source software is of course Saga GIS, or System for Automated Geoscientific Analysis. It is one of the classics in the world of free GIS software. It started out primarily for terrain analysis such as hill shading, watershed extraction, and visibility analysis. Now, Saga GIS is a powerhouse because it delivers a large growing set of geoscientific methods to the geoscientific communities. Enable multiple windows to lay out of your analysis, maps, histograms, scatter plots, attributes, etc. It provides both a user-friendly interface and API. It's not particularly useful in cartography though, but it's lifesaver in terrain analysis. Closing gaps in raster datasets is very easy in Saga GIS. The morphometry tools are unique, including the Saga Topographic Wetness Index and Topographic Position Classification. If you have a DM and don't know what to do with it, you need to look at Saga GIS. Overall, it's quick, reliable, and accurate. Consider Saga GIS as a prime choice for environmental modeling applications. Now, as we learned about GIS software tools, let's talk about the geodata and GIS data sources. That is the topics of our last two lectures on this course. Welcome back, students, to our course on learning GIS with QGIS. QGIS is a professional GIS application that is built on top of and proud to be itself free and open source software. It is currently one of the most popular GIS software that could be literally used by anyone interested. The topic of today's lecture is on QGIS and its structure and main interface features. Let's get started. QGIS is undoubtedly number one free GIS software package. QGIS is a jam-packed with hidden gems at your fingertips. For example, you can automate map production, process geospatial data, and generate very beautiful cartographic figures. There is no other free mapping software on this list that lets you map like a rock star than QGIS. The favorite thing about QGIS is QGIS plugins. QGIS plugins put this mapping software into a state of epicness. If the tool doesn't exist, you should search for a plugin developed by a QGIS community. Volunteer effort is a key to success of QGIS. The QGIS Stack Exchange support is impressively great. QGIS 3 brings a whole new set of cartography, 3D and analysis tools. Downside of QGIS that is worthwhile mentioning: frequent software updates result in bugs and changing layout of the program that sometimes make it difficult to work it. QGIS is a user-friendly open-source geographic information system licensed under the GNU General Public License. QGIS is an official project of the Open Source Geospatial Foundation, OSGO. Its latest long-term release in 2020 is QGIS 3.10, the version that I'm going to work with you. But these versions are updated quite regularly, and probably by the time you are watching this video, a new version of QGIS is already available or on its way. QGIS runs on Linux, Unix, Mac, and Android, and supports numerous vector, raster, and database formats and functionalities. QGIS the structural features of QGIS includes QGIS Desktop, which create, edit, visualize, analyze, and publish geospatial information, which is available for major computer systems, operational systems. It has also QGIS browser, QGIS server, QGIS web client, and QGIS Android. So you can also run QGIS on your smartphone. In these video lectures, we are going to concentrate though on QGIS desktop, QGIS browser, so that you will be familiar how to do GIS analysis in QGIS on your desktop. QGIS desktop surface have the main elements. Namely, number 1 that you can see here is a layer list or browser panel. Number 2 are toolbars. Number 3 is a map canvas. Number 4 is a status bar, and 5 is side toolbars. We are going to look through this in details in our following videos, but these major elements are very important to have in mind, as I'm going to mention them throughout the videos. Well, and finally, let me give you some tips on literature and resources. Even several years ago, there were no books published on QGIS. As you can see from this slide, the situation has dramatically changed since then. So currently, there are different interesting literature available on the subject, basically in commercial domain. So some of the books that I can offer you and suggest for you are listed on the slide. So Getting Started with QGIS, not bad. Learning QGIS, Mastering QGIS. This is a series of books, a bundle of books which offer you to learn GIS, QGIS from the beginning to apply it in the advanced applications. Well, over here another version of the same book, but just in one, QGIS becoming a GIS power user. Beside of the books, there are also some interesting and useful web resources that you may want to investigate in the future. So first of all, there is the website of QGIS that I'm going to show you in the upcoming lectures, that of course are going to be one of your main sources of information on QGIS. There is also a nice site which is called From GIS to Remote Sensing, which is specialized on semi-automatic classification plugin. I also encourage you to look at the help of QGIS, because there are different QGIS tutorials and tips that for sure you will find very helpful. And in general, it's a good practice every time if you have any problems or question to the software, whether it is QGIS or ArcGIS, it's always very helpful to first look at the tutorials and tips and the help section of the software and others. So you have also links on this slide, so you can also, I encourage you to also investigate those resources outside of this course. Good afternoon, everybody. Today I'm going to show you how to install QGIS software on your computer. This video lecture is not going to be long because it is quite easy and straightforward procedure. So first of all, where you should go is to visit this qgis.org website. This is website of QGIS software, where you not only can download some software, but also discover more about QGIS. So here we are on the start site of this, the starting page of this website. And what is probably interesting for you is if you are not native English speaker, you can also change the language of the website to the one that you really need. Well, for the sake of this video, I will keep the language to English. And what is interesting in this web page is, of course, also to get a little bit more information about the project of QGIS. So here you can see the menu on the app, discover on the upper part of the website, namely the options are Discover QGIS for users, Get Involved, and Documentation. So basically, let's click on the first one, Discover QGIS. Here you will find some interesting information about QGIS project, community behind the QGIS project, and other interesting information. You can also browse through, you can see different applications of QGIS. what is QGIS server. So basically you can go through each and every of these bookmarks, and I'm sure if you are serious about learning GIS and remote sensing and you would like to be a profi and expert in using QGIS, you would find this information quite useful. We have also here map examples. This is very quite inspiring, and I would also recommend you to browse through it, because it can give you, let me just click on one of the examples here. We can see some map. It looks like a topographic map. Basically, I don't know which language it is. Looks like Polish probably, or maybe Slovak or Slovenian. But anyway, as you can see here, we have a number of different examples of exciting applications of QGIS. With this, of course, is very inspiring when you just starting out with QGIS. Okay, let's move maybe to the documentation. This is the last one option here on the website, and basically also this is also quite interesting for you to look at it, because here we have such useful documents as a user guide, QGIS user guide, QGIS training manual, a gentle introduction to GIS. So basically different interesting materials and documentation which are directly connected to QGIS, and which for us as a users might be important. Okay, this is just introduction to QGIS website, and now let me go to return to the main page and show you basically how should we install QGIS. Well, here you can see there is two different buttons. One is download now, and another link support QGIS. So basically download now, we can click it. I will open it in a new window. Will forward us to the download QGIS platform, where you can see different releases of this software. So here a few words about different differences in releases and versions of QGIS. Well, first of all, we have different differentiation of the QGIS according to the platforms that you are using. So let me make this small, and you can see that we have different options. So software available for downloading for Windows, for Macintosh, for Linux, and two more options for BSD, as well as you can actually test and run QGIS on a mobile device or tablet. I haven't tried it, but might work. So since I'm a Windows user, I'm going to show you the installation for Windows. I'm sorry that I can't really help you with Macintosh or Linux installation, but I would assume they are quite similar and straightforward. Regarding functionality of QGIS program software, depending on the platform you use, this is a little bit different, and the interface could slightly differ from Linux, Macintosh, and Windows releases. So I also have prepared all my practicals, as well as the videos that I have recorded for you are based on version for Windows. So you guys please consider this, that it might slightly be different from the version that you will use in case you are not a Windows user but Macintosh or Linux user. So I again go to click on download for Windows, and here we have different options. We have latest releases options and long-term release options. So latest release options are those versions that are experimental. They are currently being developed. The new features are adding. The bugs which are already detected in the previous versions are fixed. So basically those are the latest releases. what is nice in the latest release is that some new features could appear in those software, in this latest release software of QGIS. But at the same point, the problem is that those versions were not tested as much as long-term releases, so they are not that stable. Yeah. So for my practicals and also for my teaching that I do, I always use long-term releases because, as I said, they are more tested, the bugs are known or fixed, and the interface is familiar, so those are more stable versions. And I also, therefore, provided you installation for a long-term release version. So here we will work with installation of QGIS installer version 3.10. And well, basically, if in a practical it was meant that the version is different, then it's not a big, should not be a big difference. It might be a slight changes in interface, but in general, this is not a big problem if you install 3.10 version instead of 3.4 or 3.0. Basically, the versions, they do differ little bit the interfaces, but in general, some features of the basic features remain the same. So then once you are here on this page and you have decided whether you want to download the latest release or long-term release, then you have to think what kind of machine you have. Is it a 32-bit machine or 46-bit machine? In my case, it is 64-bit, so I need this version. I click on it, and basically you can see that the downloading process is starting, and as soon as basically it's finished, you can click on it and wait a little bit, and then the dialog window appears, which asks you whether you really want to start installing the software. Well, I click yes, and so I click twice, so I don't need it. Okay, so basically when you click yes, you will the dialog window appear where you can start installing software on your computer. You click here next, and a license agreement will appear, which you can go through basically, and you should agree if you want to continue. Then the standard procedure, you have to choose where you want to install your software. In my case, it is often the same folders. C on the disk C, program files, QGIS 3.10. Probably it is the same for you. You click next. Here the QGIS has an option to install together with QGIS the files, the data sets which could be used for training. Since I have all of those data sets, I would not include them in this video. So you just click install. And the installation process starts. You have to wait here some time, usually depending on your computer, but usually installation does not take us a few minutes to complete. And when the installation processes will be over, you will receive a message from QGIS. So let's wait a little bit. Basically, when the installation process are finished, you will see the dialog window which says that the installation has completed, and click finish to close this wizard. So let's do this. And after this, you can go to your Windows menu. Basically, I'm using Windows 10 computer, so if you use the same computer, it will be very similar. So, and as you see, On the top, you will see recently added files, and you will see QGIS desktop version 3.10.4 and the same desktop version with GRASS. I would recommend you to use with GRASS, for example, or you can simply click search and, for example, click on QGIS, and then you will find this. But since you can see I have different versions installed on my computer, you have to be careful which version you would like to use. So let's start with the version which we just installed with you, which is 3.10.4. I clicked on it, and you can see that the long-term release QGIS 3.10 is launching. And here you go. Well, you can, the QGIS is opened. Here I have different projects which already were transferred from my older version to a new versions, and basically we can start using the new version QGIS for geospatial analysis. That's it. Thank you for watching, guys. Welcome back to this course. Today I'm going to show you how to install different plugins in QGIS software. For this, please open your QGIS software. Here is my interface, and the project that I have opened is also seen here on the top of the menu. And basically, in order to load more plugins in QGIS, we will have to work with a menu bar which is called plugins. What is QGIS plugins? Well, basically the whole power of GIS analysis in QGIS is powered to great extent by the QGIS plugins. QGIS plugins are developed by a community, by QGIS community, and basically could be accessed via plugins repository, which is found here on the top of the menu of QGIS. In order to install plugin, you have to go to a menu called Manage and Install Plugins. Here the such window will open, where your dialog window where you can see the installed already plugins. In my case, it's only one, semi-automatic classification plugin, and non-install plugins. Basically, the number of the plugins available differs from QGIS version to QGIS version. So the versions of QGIS that are older or usually have more QGIS plugins, and the newer released and experimental released usually have less available plugins. This is because the QGIS plugins are developed by a community, by the developers, and should usually be updated when the QGIS is transferred to a new version, which is of course extra work for the developers and not always is the case. What could be the solution for this? Well, the solution is to keep different versions of QGIS on your computer, which is also a beautiful thing about QGIS. You can have several versions of QGIS software installed on your computer simultaneously. Basically, now I'm going to show you how to install some of these plugins. Let's see basically what we have here. Maybe let's find something interesting. Well, for example, plugin which is called Sentinel-2 download. Sentinel is a satellite by European Commission, which is a part of the Copernicus program of European Union, which delivers optical data with a high spatial and temporal resolution. And you can also, by installing this plugin, download it directly to your QGIS software. Well, here what is interesting to see that each plugin has its title, short description. It sometimes give you also several informations about for what you can use this plugin. Then you have votes, ratings that you can also rate by yourself. Basically here it's only 5 ratings. You'd see not so many people have downloaded. It's only 1,000, which is basically not that much. And also here you have their author who has develop this plugin. In order to install the plugin, you have to click install, and installation process will start. Later on, you can also uninstall plugin. Here is the button. Okay, we can also, for example, try with another plugin, Sentinel Hub plugin, which enables users to harness power of Sentinel Hub services directly from QGIS. Again, we have a small description section, very good so far ratings, not much of them, not many of them, only 41, but you see people leave excellent feedback, and you have a number of downloads. So you basically click install, and here you go. Their installed plugins are now available in the installed pane of this dialog window. Here you can also basically use this window to manage your plugins. You can, for example, some of these plugins activate or deactivate. For example, we have recently installed Sentinel Hub, the plugin. I can click and unclick it, and you can see when I here there's this plugin. When I unselect it, then it disappears from my menu toolbar. Well, semi-automatic classification plugin is very important plugin, guys, and I encourage you to install it. I have installed it here in my QGIS version, and I have it almost on every my QGIS software versions. And why it is important? It's because, let me click on it, it allows for the supervised classification of remote sensing images, providing tools for the download, the pre-processing and post-processing of images. This is very handy plugin, and we also can use it for image classifications, and which allows us in a quite straightforward manner to produce land use and land cover maps. This is how this plugin looks like. You can again move it around your interface, make it larger, smaller, explore the plugin, and you can also either pin it to any place in your QGIS display, or you can also just close it and activate again when you need it. For this, you can go to panels and choose SCP doc, which would allow you to see again the plugin, semi-automatic classification plugin. Well, what I would like to recommend to you that now you customize your QGIS software, you install several plugins, well, the ones that I have recommended to you in the document, but also you can basically just explore by yourself, click around, see what you would find which could be interesting for your plugin. For example, the one plugin which I was talking about in installation guide is XY2Point plugin, which you can also install. Well, just have a look at what is available, explore, and try to install and install several plugins that you just get a feeling how it is done. Hello guys, and welcome back to our Hello guys, and welcome back to our course. Now I'm going to show you how we can explore QGIS interface, and we are going to do it together. So please open up your QGIS software and let's get started. Basically, the first thing which you will see is when you go to QGIS software is basically the new project interface, unless you have already projects that have been created. And on the top left corner you will see how the project is called, because it is the new project. In my case it is untitled project. So to show you a little bit more about interface and navigation, let me use some of projects that I have already created. So in order to open already existing projects, you go to project, open, and create select the project that you have already pre-selected. So in my case, what you can directly see is a layer panel. This is a panel which show what kind of raster vector layers are currently ingested in your project. In my case, I have two layers. One is a vector layer which shows the polygons, the result of segmentation of satellite image, and another layer is actually the satellite image by itself. So and you see here you can select those layers. You can also right click on it and go to the properties and select, for example, remove layer if you want to remove it. Okay, so this is a layer panel where you basically manage different layers. On the top of the window of QGIS window, you will see a menu. This menu shows you different options how you can deal with the different parts of your project, QGIS project, and analysis related to different type of the analysis. So the first menu bar is project, where depending on there are different functions and operations that are connected to the management of your project, such as create a new project, opening the project, so saving the project, and etc. So important is to save projects as well. I'm emphasizing it right now, as it sometimes we forget when we start doing GIS analysis that we have to save projects. But this is very important tick. When you make changes, you run analysis, add data, please don't forget to save it. The second menu bar is edit, where different operations related to editing of data could be accessed. View basically is a main menu bar and where all different options for customizing QGIS main interface are located. So here let me show you two different interesting for us options. The first one is the panels and the second one is the toolbars. So in panels, here you can select different panels that you would like to be added to your QGIS interface. So the ones that are pre-selected are the ones that you can directly see in your interface currently, and as you can see, for me it's on the layers. So let's click on browse. So when I clicked on this toolbar, the new another dialog window appeared, which is basically show you how you can browse through the catalog of QGIS. The browser panel is very much similar to the ArcCatalog option in ArcGIS, for those who are familiar with ArcGIS. Let me show that you can actually move around those panels. You can put them on your side of your computer, of your window, you can put them on the top of your interface, you can basically put them down, so it's very much customizable depending on your preference, where you want to have it, whether you need it. You can put it a different part of your screen. Basically I don't need it, therefore I will just close it. Okay, here's a Python console. I also don't need it, but I need my layers. So I will put this layer panel back to the left part of my window. So if you want to add some new panels, you have to go here and click on the panel that you need. Toolbars. This is also important. The same principle applies as with the panels. The ones with the hex showing the visible toolbars on your top of your window, and here you can also add some toolbars or remove some toolbars from your view. You can add the ones which you need for your work and remove the ones which you don't need. So let me remove some. For example, let's remove these two toolbars related to semi-automatic classification plugin. When I click it, it's just removed it. But then I would like to add, for example, snapping toolbar, and as soon as I clicked on it, I now can see the snapping toolbar here appeared on the upper part of my QGIS interface. I can also move it around, and for example I can put it here on the right hand side of my computer. So guys, I do encourage you to play as much as you can with the interface. Don't be afraid to explore, to click on different options, to move around different panels. This is the only way how to explore QGIS interface. Well, for example, we have here also an important identify features tool. If you click on it, your mouse, you can see now it's changed, and let me bring it over my segmentation layer. I clicked, and now I can see information on information about this polygon, because it's a value tool. And here is basically identify results of this tool. Yeah. So again, you can put this panel wherever you want. You can unpin it, pin it, depending the size could be, I guess, changed. Yes, depending on your preferences and liking. Yeah. Okay. So after what I encourage you to do now is to explore your QGIS interface, to customize it as much as you would like to explore different options, to click on different tools, to see how it works, to see what panels you would want to add, what kind of toolbars you would like to add, and to customize your interface as you would like to. Another probably important part to mention in the interface of QGIS is here the part on the bottom of the window. Here basically you have a coordinates. So if you bring your mouse over here over my image and segmentation layer, you can see that the coordinates change. Yeah, so basically this is important when you need to find out the coordinate, for example. And here you can also choose the scale which you like to look at. So it's very similar to basically ArcGIS. Magnifier tool, here you can select whether you want 100, 150 or 50%, or you can also customize it if you just type how much percentage you want to magnify, rotation, and here you also have always information about the special reference of your layers, which is also an important information.